Welcome back. In this video, I'm continuing daily Leetcode question, and for today, that's problem 3016, minimum number of pushes to type word number 2. So, we are given a string word containing lowercase English letters. Telephone keypads have keys mapped with distinct with distinct collections of lowercase English letters, which can be used to form words by pushing them. For example, the key 2 is mapped with ABC. We need to push the key 1 time to type A, 2 times to type B, and 3 times to type C. It is allowed to remap the keys numbered 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the keys will be pushed to type the string word. Okay, return the minimum number of pushes needed to type word after remapping the keys. An example mapping of letters to keys on the telephone keypad is given below. Note that 1 asterisk and hash and 0 do not map to any letters. Yeah, I would say B, C, D, E, A, B, C, D. Okay, so essentially we can map each letter everywhere, and each key can be as much as we want letters, but since we have 26 letters, we need to, and we need to map them in such way that we have the minimum number of keys. That means we just find the number of each letter, a number of we count each letter, and then we essentially just assign the numbers, the keypads to the letter, it won't be loud now. So we just remap the keys to the letters in a way that the letters with higher frequency are assigned first. So when we have, let's say, 15 distinct letters in this word, we count occurrences of each letter, and then by the frequency, so the most frequent, we start first with most frequent. They're assigned first, let's say from 2, 3, 4, 5, 6, 7, 8, 9, and so on. So those letters will have only one key press to get them, and then we for the rest of the letters increase, like just put them here and here. So essentially we divide the number of distinct letters by 8, and then rest will have the frequency lesser than those before, will be assigned, so 2 presses of the key. I hope it makes sense. Maybe I explained it a bit weird. Well, I'll call it up. It will probably make sense more there. So what do we need? We need frequencies. So we need to count them. We can use counter for that. So counter word, but we do not want word, but we are interested in values, actually, because not the keys, and we want that value sorted. So we need to sort them, sorted counter word values, but also we want them in the reverse order, so we need to put reverse true equal to true. Okay, this should be good. And now we have frequencies in decreasing order, and we need to calculate the number of times we need to press for this word. We just do total is equal to 0. And so for we can do count value in enumerate fracs, and total is plus equal value times so count divided by 8, but we start from 0, so when we get to the 8, that's 1. Okay, but we need to also have 1 because when we're having elements, first 8 distinct elements, we'll get 0 here. So we need to have 1 plus c divided by integer division by 8. So yeah, for the first 8 characters, that's 0 to 7, this will be 0. So we have 1 here. From 8 till 15, this will be 1, and 1, that's 2, that's okay. And from 16 on till 23 and so on. Yeah, okay. And now we just return total. Let's see if this works. Okay, it's accepted. And yeah, it's correct. For the complexities, so we have counting and sorting here. Counting is so for counting, that's often because we need to pass all elements of input. And sorting, we actually sort only 26 essential letters, because there are only 26 letters of English alphabet, lowercase English letters. So yeah, this should be O of 1, because 26 times log of 26 and log n in this example is 26 times log 26, so that's O of 1. So we have O of n here, and also this this frags list will have only 26 values, so this is also O of 1. So totally time complexity is O of n, and space complexity should be O of 1, because we have only 26 elements, so counter will have only 26 keys, and frags will also have only 26 values. So yeah, should be okay. Maybe we can see it here. And log n. Yeah, but not sure. I think it should be O of n, because sorting is done on input of size 26 always. And that maximal is 26, and yeah, don't know why, a bit weird. Space complexity of n, yeah, it's also weird. Not sure if it's correct. Yeah, not sure if that's correct. If you know the reason, write a comment, but yeah, I think this is the right time and space complexity. Okay, thank you for following this one, and see you in the next one.